Considering it's only 22 kilometers across, Phobos is one very interesting moon. It orbits closer to its planet than any other moon in the solar system. Its orbit takes it so close to Mars, only 6,000 kilometers from the planet's surface, that it orbits the planet faster than a Martian day. In fact, standing on Mars, you'd see Phobos rise and set twice in one day. It's so close to the planet that you must be standing near the equator to see it. Anything above 70 degrees latitude means the curvature of the planet would block your view of the moon. Being this close to the planet means that the tidal forces exerted on it are comparatively large. So much so that scientists believe that Phobos only has around 50 million years to live before it is eventually pulled apart completely and its debris crashes into the planet. You can see signs of this process on the moon in what scientists are calling stretch marks. The moon is thought to be made of rubble, and with powerful tidal forces exerted on it, fractures have started to appear as the rubble is pulled apart. Because of its close orbit, its orbit is also degrading or spiraling inwards by 2 centimeters a year. When Phobos is eventually pulled apart, a small portion of the debris may remain in orbit around Mars for a few million years, meaning Mars would have rings for a time. But from a hypothetical standpoint, is there anything that could be done to stop Phobos' demise? It's only 22 kilometers across. Surely all you would need to do is stick a rocket on it and boost its speed a little to give it a higher orbit. Well, let's say we wanted to increase Phobos' speed by 1 millimeter per second. In order to accelerate something in space, we need to throw some mass in the opposite direction. So, knowing that Phobos' mass is roughly 1 times 10 to the power 16 kilograms, gives us our required change in momentum. Next, we need to figure out how fast we are going to hurl this mass away from Phobos. Let's say 20 kilometers a second, which gives us the amount of propellant we require, 500 million kilograms. Shooting that much mass away from Phobos at that speed requires a lot of energy, 10 to the power 16 joules. That means to increase the orbital velocity by only 1 millimeter per second, we would need to shoot out the equivalent of an Empire State Building with the energy of a nuclear bomb. As it happens though, we would just need to counter the orbital decay of Phobos, which is slowing down the orbit of Phobos by roughly 0.002 millimeters per second over the course of the year, which gives us our drop of 2 centimeters a year. We can counteract this by using roughly 30 grams of propellant per second over the course of a year. This still adds up though. That's equal to 1 million kilograms per year, plus the energy required to shoot it out. So could we eventually save Phobos? Maybe. It would require a lot of resources though, just to counteract its orbital decay, let alone raise its orbit. A 22 kilometer moon doesn't seem very big, but it is still 2,000 times heavier than all the coal mined on Earth each year. Well, thanks for watching, and a big thank you to my patrons this last month. Your help to support this channel really does mean a lot. If you want to support too, find the link here. If you want to help the channel in other ways, subscribing, liking, and sharing makes a big difference too. All the best, and see you next time.